Good morning everyone. Today I am presenting my D4 custom project implementation task where I have developed the program I initially planned in the D2 custom project task. Uh, Let me first show you the D2 custom project plan, the basic logic of the game, and this is what it looked like in that task. And now let me show you the progress I have made. This is a little demonstration of the code I have made for this task. Let me show you. The yellow circle is the Pac-Man here. Meanwhile, the reds are the food items, but this gray one, which is the poison, and the game is over. So now let me walk you through the code of the game. Starting with these are the libraries, Slashdot and CMAT. I've used this Slashdot library for all the graphics and the input handling, and I have used a square function in the code. This is the square root function I've used, which I've taken from the CMAT library. Now I have initialized some radiuses and speeds. Then I've made two variables, maze height and maze width. Maze height here is the rows and maze width is the columns. Basically, I have this basic blueprint of the game where I've divided the window into a 15 grid of boxes. So for making this, I have used a 2D array of strings where 1 represents walls, 0 represents the food, and P represents the poison. However, I leave one space empty where I have made my Pac-Man in the game. Then I made a structure for Pac-Man in which I have initialized the coordinates of the Pac-Man and the radius. Moving forward, this function is used to move the Pac-Man to some specific location to ensure that it doesn't overlap with the walls. First of all, we have given this two arguments x and y, which represents where Pac-Man is trying to move. By dividing these by 30, we are finding the row and column in which the Pac-Man is standing. For example, if I see it here, the x is 210, let it be 210 from here. Then if I divide by 30, that means it's the 7th row. So this is how we are calculating it. Then we have used this if statement to keep the Pac-Man constructed into the screen and not let it out. Now the next function, draw game function. This is my next function in which we have called for the struct and the score. The initial score is 0. Then we have made the Pac-Man and cleared the screen. Then we have used a nested loop to make the food items, poison, and the walls at the places of 0, p, and 1 respectively. Then the distance between points function, in which I have used the Pythagoras theorem to calculate the distance between any two objects in the window. Here x1 and y1 are the arguments for object 1, and x2 and y2 are for the second one. Then I have made two collision functions which check the collision between the food and the poison. I have called the above function here so to check the distance between a Pac-Man and a piece of food, and to check if they actually collide when the radius of Pac-Man and the food is smaller than the combined radius. This is how the function and the collisions check. Then moving forward, we have the round function. This is starting window. Then we have initializing the coordinates of the Pac-Man and the radius. Then we have initialized score as 0. Then we have started a while loop which let the game run until the user quits. Then we have used the key down functions to move the Pac-Man right, left, downward, and upside direction. But we have also limited the movement of the Pac-Man by calling the can move to function from above. Then we have used another nested loop for checking the collisions and use the if statements. If it collides with 0, that means the food and score increases, and at the place of the 0, that means at the place of the food it becomes an empty space. And then else if we have shown that if it collides with poison, it shows the game over message and the game ends. Then we have called for the draw game function to draw everything else, and then we have made this if statement so as to say if the score is equal to 18, we have to relate to items. So if the user collects all of them, then the message will be shows, otherwise game over shows. And then we have the main function in which we call the round function. Then let me show.